Hamish. You FaceTime, come right here, okay? Right here, subscribe, let's go. I'm Hamish, by the way. Let's get started. So we have a question here. So this is more of the potential electric, okay? Now let's say the question. They say 4 pins are chargers. So you have it, 4 chargers, individual brought from the infinity. You know, infinity somewhere very, very far. We don't know where. So we brought 4 chargers, you know, and placed at a corner of a square. Oh, so this is square. So place one charger, one charger, one charger, shown in the figure below. So this figure right here, each charger has a direct value of Q, positive Q. So this is positive Q, this is positive charger, and this positive and positive charger. So what happened? The length of the diagonal of the square is 2a. Oh, so the length from here all the way is 2a. This is center. So this is 2a. So if this is 2a, this square, we know this is going to be a. This is going to be a, same here. You know what I'm saying? So this is going to be a, and this is going to be a. From here to here, a. The whole diagonal 2a, and this diagonal is 2a. And then what happened? Now let's say place at the adjacent like this corner here, adjacent of the corner. So they say what is the electric potential? So from the Coulombs, you know what I'm saying? From the Coulombs law, we say this is very, very easy, man. So let's get the electric potential. So we say, so there's 2 questions. Find the electric potential energy of the 2 charger, and the other one electric potential P of this at the center. So you know what? Let me start with the second one. You know, it doesn't matter what the first one or second one. You know what I'm saying? Now let me start with the second. I prefer to start with the second one because the second one is like it has it all. Okay. Okay. Now let's go for the second one. So for the second one, we say so electric potential always from the Coulomb law we say equal to K. Okay. So since this is the center, so say K times. Let's start from this P. To let's call this Q1, let's say, but I want to all them are equal. So P to this Q, so let's call this Q1. So let's call this electric potential 1, Q to that one, and then you over by distance from here to there, because I want to get electric potential from P to Q1. So you must take the formula. Always say electric potential equal to K times by charger over distance. You know what I'm saying? That's electric potential from the Coulomb's law. Electric potential. Electric potential. So for this case now we say here to there. So what is the distance here? A. Instead of say R, I want to say R is A. Our write this is A. So that's for V1. What about V2? V2 means from here. Let's go. This is 2. So it's going to be the same thing. It's going to be K times this charge is Q2 over what is distance? Distance equal to A. Now for V3, same thing. V3 equal to K. Okay, let's call this 3 and let's call this is Q4. So this is going to be Q3 over what is distance? A. So same with 4. Electric potential 4 equal to K4 Q4 over A. But we know Q1, Q2, Q3, they're all Q. You know what I'm saying? But sometimes they might change in exam, you know what I mean? But for this case now, they're the same. So you say charger 1 equal charger 2 equal to charger 3 equal to charger 4, which equal to QA is how it was given. I just wrote Q1, Q2 just so, you know, for you to understand, okay? So now we're going to say now total potential, total electric potential, let's get total electric potential at the center, that's what I start from this, at the center P2 or about P2, or you can say about what? About Q, about all the Q1, Q2, Q3, and Q4, which are all equal, means Q1 and Q2, they are all the same to each corner, to each adjacent. You can say to each adjacent, to all the adjacent, or to adjacent, whereby Q place. You can just do adjacent, it's fine. You know what I'm saying? Equal means you have to say V total equal to V1 plus V2 plus V3 plus V4. So we got all this information. Excuse me. So I can just plug it in. So we can say this same say V total equal to V1. Okay. So what is our V1? Our V1 equal to K Q1A. So we say K charger 1, which you know charger 1 equal to, but we say here charger 1, charger 2, charger 3, charger 4 equal to Q. So I can just say Q, you know what I'm saying? Because this Q1 equal to Q. okay, over A plus, same here, so this is going to be K, also charge 2 also equal to Q, over distance from the P, about P, center to each plane, also this A. But if they give, let's say, whatever they're going to give you, let's say 5, this is 1, this is 2, this is 4, you're going to plug in, depend on, based on the information they have given to you. So plus K, charger 3A plus K over A. So what is going to give you? This is going to give you 4Q, okay, 4 of these in other way. So now we're going to say total electric, what is the electric potential P at the center of P. Oh, so now we finish, okay. So this equal to 1, 2, 3, 4, the same thing. So 4 of KQ over A. You know what I'm saying? Or you can just put the common denominator and then add KX plus KQ plus KQ by Q. You get 4 of them. But voltage you measure in volt. So this is the electric potential at P at the center of a square, if you have this information. So now for the first one, so this was the second one, okay? So for the first one, look, what do they want? They say, what is the electric potential energy of the two charger? Oh, potential energy of the two charger. Easy, man. You know what I'm saying? It means now I'm going to be dealing with it. These two. Okay? So only I'm going to take only 2. So I don't need 4. Okay? So I'm going to say of the two charger, for the second one, for the first one now, electric potential, the two charger, electrical potential energy of these two chargers, electric potential energy of these two charge, excuse me. So we say, oh, so let's get electric. Okay, now let's go for the first one. For the first one is more easy, you know. So now the first one, which is the actual question they gave to us, I think it was like an extra question that I just put it on so you can get to understand. Now this you can get to understand what is the electric potential energy. Electric potential energy. Okay, so this is a formula. You see there's two different things. This is electric potential. But this is, you see here, this is electric potential at point P, which we got it already. But for the first one, they say electric potential energy. So we have a formula for electric potential energy. So this, let me go. Okay. So we say electric potential energy, O is equal to constant, and then you take the first charger times the second charger over the square of the distance in between. You know what I'm saying? So that's how you get electric potential energy. This electric potential energy. Now we go. So now we charger 1 we have, charger 2 we have, and the square distance. What is the square distance? The distance of separation. Excuse me. Arrow for this case, this arrow represent the distance of separation. Distance of separation. Distance of separation. Okay, so we're gonna say electric potential energy equal. Okay, K is constant, so you can just leave the how it is. What is the first Q? It's just a Q, we know. Just a Q. Second Q is just a Q also. Over, what is the distance between? Distance between, so now we don't have a distance between, but we have A, we have an A, so we don't have this. You know what I'm saying? But we can try to calculate it here. So how are we going to get it? Let's see. If this is A, like we have, oh, okay, look, I can say, so we know this is 90 here, and we know this is 90, because this is square, so everywhere is 90. So what happened? This is going to be 90, this is going to be 90, so it means this is going to be 45, and this is going to be 45. I have A, I don't have, but I can get this. So I just want to get this distance of separation here. That's a tricky part, but how can I get it? It's easy, man. So how are we going to get this out? But I know my Q, this is the same charge at Q2 and Q3, because they say, excuse me, they say of the two charger, anyone. But I will know Q, everywhere is QQ. So if I say Q times Q is going to be Q squared. So here I can just plug, you can say Q squared. So the problem now is to get what? To get this R. How are we going to get R? Okay, let me grab the triangle here. Okay, so I'm gonna grab and try it because all the same. So I'll say, okay, if I grab this is A. This unit is 45. This is 90. And this is 45. So this is my hypotenuse. In my intention, I want to get this distance. If I get this distance, because we want to get the distance separation. If I get this distance here, it's going to be same as the distance here. So which angle should I use if I want to get this distance here? It depends, whatever. So I gotta use one angle. I can use sine rule or cosine rule, or whatever you want to use. Okay, let me use sine rule. Yeah. So sine rule, if I want to get here, let's say this is x. I want to say sine of 90 over a, or a over sine of 90, because you take this length over sine of this, sine of 90, equal to this x over sine of 45. So my intention, I want to get x. Is acceptable to say, please take this, divide the sine of this, and then take this x over sine of 45. So we want to get what? X. So I'm going to get x multiplied by sine of 45, multiplied by sine of 45 throughout. So multiply by sine of 45 here, this and this cancel, and here also going to multiply by sine of 45. Excuse me, now visible to, okay. So what is sine of 90? Sine of 90 equal to 1. What is sine of 45? Sine of 45 is square root over 2 over 2. Oh, so it's going to be a times, because this sine of 90 equal to 1, so a times sine of 45 square root of 2 over 2. So square root of 2 over 2 equal to x. Oh, so what is our x? Our x, we say this, which is this length here. Oh, so for that case, this is going to be square root over 2 over 2. So now, I'm going to raise this one now because I don't need it, got it. But make sure you write this, right? In your calculator. Example. Okay, so here, make sure you show this solution, which is shown. This is square root of 2 over 2a from here to there. Even from here to here also is square root of 2 over 2a. So we have to add them. Square root over 2 over 2 plus square root over 2 is going to be 2 square root over 2. Okay, so this is separation is going to be 2 of these. So all this length here equal to 2 of these, which is 2 square root over 2 over 2 over 2a, which is just a square root over 2. Because this is a half of square root over 2, a half square root over 2. When you add them together, 2 and 2 cancel. So it's just a square root over 2. So all this length, because this and 2 is cancelled, so this, like say, all this length from here to here is just a square root over 2a, because this 2 and 2 cancel. So all this distance of separation. Oh, so now we know distance of separation. So we're going to say our potential energy, our electric potential energy equal to kq square over, what is the R? Square root of 2a. But what happened? We must want to shoot square. So this is going to give us kq square. But when you square root of a, you're going to get a. And when you square a, you get what you get? When you square root of 2, you get 2. Excuse me, because you take square root over 2 square, you get 2. And a square equal to a square. Oh, so finally, our electric potential energy equal to k q square over 2a square. So now let's do the same question, but now let's find the electric field. You see, I'm just giving you the whole package, okay? So let's do electric field now. That's find the electric field. Woo-hoo. Okay, cool. So let's say find the, okay, let me write this question here. This one I think is clear, right? Okay. Let's say, for example, let's call this question number 3. Now they say find, okay, what is the first question? The first question was electric potential energy, and the second one was electric potential at P. You know what I'm saying? Now let's say, for example, somebody place point M here between these 2 points. Somebody place point M here between the 2 charges. Now they say find the electric potential at point M between the 2 charges. So find electric potential, not potential energy, no, because, okay, find electric potential electric potential, electric potential at point M, at M, electric potential at M. Okay, now number 4, let's say find electric potential energy at P. We want to finish all this topic, man. Electric potential energy at P. Yeah. Well, no, we cannot do that because you don't have a charger. Okay, let me just write P, just for fun, and then I'll explain to you if it can be possible now. Okay, another question. Let's say find. Let's say find electric field at M. Electric field. Electric field. Find electric field at let's say at P. Find the electric field at P. Yeah, let's say find the electric field at P. And then number 6. Find I'm trying to think, bro. Find the electric field at M. Electric field at M to Q1. Okay, so now let me try to play around here so you can have a clarity and understand. Okay, now let's solve for number 3. Find the electric potential. Find the electric potential. So let's get the electric potential. Okay, let's get the electric potential at M. Oh, electric, this is not energy, right? So okay, so electric potential, we know this is what represented by potential, electric potential, equal to KQ over radius. You know what I'm saying? So electric potential at M. Oh, so now we say okay, this K is just a constant, so from M to either. So we say, we know this is Q, but if they say 4, let's say this 4 Coulomb, here I'm going to say, let's say from M to A, means I was going to say equal to, I have to check the charge if it's 4, say 4 Coulomb. From M to Q, whatever charge they're going to give to you, of where you're heading to, that's the charge that you're going to take. You know what I'm saying? But for this case here, since our Q is just a Q, so over, from here to here we got it, which is equal to square root of 2 over 2a. That's the distance from here to there. We did calculate it. So what we can do now is going to go to the top. This 2 is going to be 2k over q, and then square root over 2 over a. You know what I'm saying? So this is going to be the potential, electric potential at electric what? Potential at M2 Q1. So it depends to whichever points they're going to mention. So all you need for electric potential, you need one charger from wherever you are to one charger. So we done that. This is what we know, electric potential. Now, number 4, find the electric potential energy. Okay, find the electric potential energy. Let me say, no, this don't make a lot of sense. We're saying, let's say electric potential energy between 2 charges. Okay, so electric potential energy. Wow, this is going to be the same. Okay, electric potential energy. Potential energy. So the moment they say energy, use this formula here. And they say K, the first charger, times another charger, let's say charger 1, charger 2, over the distance of separation. So for this case here, it's not radius, it's the distance of the separation. So that's okay, electric potential energy between the 2 charges. Let's say this and this. So we're going to say, okay, so okay, So from here to here we know, which is this is a half and this is a half. You put them together, it's going to give us charger 1 is Q. So if they say, for example, 5 Coulomb, it depends in exam. Sometimes they give you put your 5 Coulomb, but for this case it's Q times this is Q from the given equation. They're all equal charge. It's going to be Q times Q equal to Q squared because the same charge times the same charge. Okay, what is the distance separation? We know square root of 2 times A. So this electric potential and the two charge. Now, they say find the electric field at P. Oh, now this is another thing now, electric field. So for electric field always equal to, take your electric potential you over by R. Okay, so electric field at P. What is our P? This is P. Oh, okay. So we're gonna say that our electric field, or the space not gonna be enough. Electric field at P equal to, what is electric potential? Electric potential we know is K P, because you know here P to anywhere is the same. A. So I could take here to there, here to anywhere. You know what I'm saying? But at some time in exam, they might say from P to whichever point. So it means you have to take that distance from P to wherever. From P to, let's say M, I'll say, oh, P to this one. So what is the distance here? So I'll say, okay, electric field equal to electric potential. What is electric potential? Electric potential is K and then times charger over distance. This is our electric potential. We know electric potential. Electric potential. Now over our R means, let's say P to, okay, over R. But what is the radius for this case? Is A. From P to wherever you are is the distance of separation, which is A. So this R is going to come here. It's going to be KQ over R times R squared. You know this R can come here mathematically. So now, okay, now what is the R? R radius is A. So Q over A squared. Oh, so if I want to get electric potential, is always equal to K constant. This one is always the give to you times Q times A squared. So electric potential K Q over A squared. A the radius. So you can memorize that one. Like it's not A, it means radius. So it's always like this, electric potential equal to K times charger times the radius. Okay, now we go for the last one. Electric field at M to Q1. Come on, it's the same thing. You know what I'm saying? So just like what I did here. So let's say to Q3. Let's make Q3. From M to Q3. Okay, so electric field we know equal to electric potential over R. So it's going to be K to Q3, but the charge of Q3 is positive. But if it's negative, you plug negative. If it's positive, you plug positive. So it's going to be Q, because Q1, Q2, and Q3 they're the same. So you say over Q over, what is the distance from here to here? A. But we have to over, because electric field over our radius A. But I could have used this straight away because you know electric field, but I'm trying to, make you get used to it. So we say this equal to KQ, and this A is going to come here, A squared. You know what I'm saying? So just make sure you remember that. When they say electric potential, this is the electric potential. Electric field, electric potential energy. Electric field, take electric potential over radius, which is going to give us what? Electric field. Okay. Easy, man. I'm out. Yeah, easy. We out, man. Easy, man. We done.